Hi, I'm Hawala Penina, and I'm going to take you through qualitative analysis, which is based on inorganic chemistry. We are going to look at analyzing ionic salts like sodium hydrogen carbonate. We have potassium nitrate, and we have copper 2 sulfate crystals. Copper 2 sulfate has a blue color while the rest has white. During analysis, most of the time, we test for the presence of water of crystallization, which is usually seen as a colorless liquid on the cooler parts of the tube during heating. We test for cations using sodium hydroxide or ammonia solution. We test for anions using sodium chloride. We can use sodium sulfate. We can also use lead nitrate. During heating, mostly, we take it as a preliminary test on inorganic substances, of which we are able to identify the ions that are present but not conclusively. For example, we have hydrated salts like copper 2 sulfate. If you heat them, they're able to give you colorless liquid on the cooler parts of the tube that shows water of crystallization is present, and potassium nitrate that will not give you colorless liquid on the cooler parts of the tube, but when heated is able to give you colorless liquid as a colorless gas is produced. Then we have others like chlorides, for example, sodium chloride, that will not decompose on heating using the normal Bunsen burner flame. And during heating, we have nitrates that are able to decompose and give you colorless gas only. For example, sodium and potassium nitrate. Then we have those ones that are less reactive, and so therefore when heated are able to give you an oxide, brown fumes, and a colorless gas. Nitrogen 1 oxide has a sickly smell while oxygen has no smell. And it relights a glowing splint, and the only distinguishing factor between the two of them is that nitrogen 1 oxide has a smell, oxygen has no smell. And the oxides of some metals will give us very dramatic colors. For example, we have copper 2 oxide, which is black, and most of the compounds containing copper is either blue or green. So during heating, if we use, for example, copper 2 sulfate, it will turn from blue to white, and on strong heating to black. So conclusion, mostly if you're given a solid that is blue and it turns black on heating, is that you have copper ions. Then we have zinc. Most of the zinc compounds are white in color, and on heating it turns yellow. Then on cooling the residue turns white. So we conclude that whatever substance we had been given contains zinc. The second test when it comes to analyzing an inorganic substance is dissolving. And dissolving is a process where you put a solid in water, and if it is soluble, it forms a solution. If it is insoluble, it forms a suspension that settles at the bottom. Or it may also mean that you have a mixture of a soluble and an insoluble salt. When this happens, then you need to filter so that you get the residue and you get the filtrate. It is important to state the color of the residue and the color of the filtrate where you have a mixture. Now, the solution, when it is formed, the color is very important because it leads you into coming up with the conclusions on what the substance contains. For example, if you have a green solution, then your most likely conclusion would be that you have either copper ions or iron 2 ions. If you have brown solution, then it means you have iron 3 ions. If you have a pale blue solution, you have copper 2 ions. If you have a colorless solution, then you are having absence of iron 2, iron 3, and copper ions. Next test will be use of sodium hydroxide solution that is used to test for cations that are present in a substance. It is used to test positively the amphoteric ions, that is lead ions, aluminium ions, and zinc ions, where it forms a white precipitate when the test substance in solution form is, a few drops of sodium hydroxide is added to it, and when excess is added, it dissolves to form a colorless solution. If it forms a white precipitate though, and the white precipitate does not dissolve in excess, then we know we have either calcium ions or magnesium ions. If there is no white precipitate that is formed, then the ions that we suspect could be present in the substance is potassium ions, ammonium ions, and sodium ions. If, on the other hand, we have no white precipitate, but when the substance is heated and the gas produced is tested with moist red and blue litmus paper, the blue remains blue, the red turns blue, then we know we have ammonium ions. So we test conclusively that the substance contains ammonium ions. In a flame test, you take the test substance, if it is in a solution form, dip a glass rod or a clean metallic spatula, and then burn it in a non-luminous flame. The expected results are, if you have potassium ions, it will burn with a purple flame or a lilac flame. If it is sodium ions, it will burn with a bright yellow flame. The next test will be using ammonia solution, which is used to test conclusively for presence of zinc ions. If you take the test solution, add a few drops, it will form a white precipitate. That precipitate, if you add excess, it forms a colorless solution, confirms that you have zinc ions. If the precipitate does not dissolve, it confirms that you have either lead or aluminium ions. In the next test, we are using sodium chloride or sodium sulfate solution. In the test substance that you have been provided with, add a few drops of sodium chloride or sodium sulfate solution. If a white precipitate is formed, lead ions are present. If no white precipitate is formed, then aluminium ions are present. If we use sodium chloride and the white precipitate that is formed is warmed and it dissolves, then we know conclusively that we have lead ions. So we are now through with testing cations, and now we'll embark on testing anions, and we have various reagents that we can use so that we can conclusively come up with the anions that are present in a particular test substance. So we'll start with lead 2 ions and lead 2 nitrates particularly is used for testing the sulfate, the sulfite, the chloride, and the carbonate. But in case we inferred that our cations are either potassium ions, ammonium ions, or sodium ions, then the carbonate is automatically out, because these are ions. These are cations that normally forms soluble carbonates. If we add a few drops of lead nitrate into the test substance in solution form, and it forms a white precipitate. Then we will conclude we have sulfate, we have sulfite, we have chloride, and we have carbonate present. The next test solution is barium 2 nitrate that is used to confirm presence of chloride ions or absence. To the test solution, add a few drops of barium 2 nitrate solution, and if a white precipitate is formed, then you can conclude you have carbonate ions, sulfate ions, and sulfite ions present. If no white precipitate is formed, then you have chloride ions are present. We need to differentiate between sulfate ions and sulfite ions here, and we can do that using two test solutions, that is potassium manganate 7 solution, which is purple, and dichromate, potassium dichromate 6, which is orange solution. Both the solutions should be acidified, and so if you have a test solution and you suspect it is a sulfite, you add a few drops of potassium manganate 7 solution or potassium dichromate 6 solution and warm. If you use potassium manganate 7 solution, it will turn from purple to colorless. And if you're using potassium dichromate 6, it will turn from orange to green to show presence of sulfite. If the two solutions do not change, that is, their color persists, meaning potassium manganate 7 remains purple, potassium dichromate 6 remains orange, then you know sulfate is present. Okay, test for nitrates. In the lab, when we are looking at nitrates, apart from heating that produces brown fumes, we also have other tests, like when you have a sample of a nitrate and you mix with freshly prepared iron 2 sulfate in a test tube, then you add conc sulfuric 6 acid carefully, drop by drop, down the side of the tube. At the junction of the two layers, a brown ring is formed. We can also use Devada's alloy test that takes the sample, you add sodium hydroxide solution and aluminium foil, you heat, and a colorless gas with a pungent smell is formed that turns moist red litmus paper blue. Blue remains blue. We'll confirm nitrate as being present. This has been very enjoyable, taking you through the qualitative analysis so that you can be able to come up with confirmation about the cations and anions that are present in a particular substance, what is needed, the terminologies you need to use, and conclusively come up with the identity of the substances. In future, we are going to go through many more so that you can be able to make this much more easier to approach for secondary level exam.